The James Webb Telescope is lauded as the boss overall observatory in the area of room science, perceiving itself through its unrivaled capacities. Furthermore, like some other instrument before it, the Webb Telescope's focal objective is massive and huge, including the examination of our own nearby planet group, while reaching far past to explore faraway worlds and stars light years away. Its mission isn't just to notice these divine bodies, but also to dive deep into the major designs of the universe itself, aiming to comprehend the universe's diverse complexities and, fundamentally, our place within it. In a noteworthy exertion, analysts have recently coordinated the telescope's look toward a star found a dazzling 120 light-years from Earth. The disclosures from this attempt have been totally momentous. The telescope has revealed proof of carbon-based particles inside the atmosphere of what may be a sea world beyond our planet, a discovery that has left the infinite local area dumbfounded. This discovery prompts us to ask how such an astounding revelation was even possible. This advancement provides us with a captivating look into a planet unimaginably different from any within our nearby planet group, testing our comprehension and raising new captivating questions about the potential for livable universes and the farthest reaches of the universe. This discovery marks the beginning of a journey to reveal much more about this confusing exoplanet. For those fascinated by the secrets of the universe and anxious to stay informed about such significant progressions, we welcome you to subscribe to our channel. This way, you can ensure you're always fully informed about the most recent astronomical disclosures. Make sure to share this video with others to spread the information and activate the notification bell so you never miss an update. NASA's James Webb Space Telescope has recently made a critical and significant discovery regarding the exoplanet known as K2-18b. This exoplanet, which has a mass of approximately 8.6 times that of Earth, has been the subject of intense study. The Webb Telescope's advanced sensors have identified the presence of carbon-based compounds, specifically methane and carbon dioxide, inside the atmosphere of K2-18b. This revelation expands upon past research and supports the theory that K2-18b could be a planet with conditions suitable for life. The presence of a hydrogen-rich atmosphere, combined with what appears to be a sea-covered surface, suggests that this exoplanet may be capable of supporting life or at least conditions conducive to it. The initial examination of K2-18b's atmospheric properties was conducted with the Hubble Space Telescope, which significantly enhanced our understanding of this far-off world, found 120 light-years from Earth in the constellation Leo. K2-18b orbits a cool little star known as K2-18, which exists in the so-called habitable zone, the region around a star where conditions may be right for liquid water and, consequently, life. Planets like K2-18b, which fall between Earth and Neptune in size, are a rare and fascinating class, particularly considering that our own nearby planet group lacks similar planets in proximity. The shortage of such planets makes K2-18b a particularly significant subject for study. The likelihood that K2-18b harbors a lot of carbon and exists within a hydrogen-rich atmosphere is especially interesting to cosmologists. Several specialists theorize that such planets could offer the most promising circumstances for the search for extraterrestrial life. The specific blend of methane and carbon dioxide in K2-18b's atmosphere, along with a striking shortfall of ammonia, lends further credibility to the possibility that this exoplanet could indeed have a sea beneath its hydrogen-dominated air. Early observations, moreover, indicated the possible presence of a compound known as dimethyl sulfide, which, on Earth, is produced exclusively by biological processes, particularly those involving marine phytoplankton. The presence of dimethyl sulfide in K2-18b's atmosphere, if confirmed, would be a remarkable indication of potential life. However, current data on dimethyl sulfide is not definitive, and more robust evidence is required to validate this. Future observations utilizing the Webb telescope are supposed to provide further clarity on this, potentially affirming the presence of dimethyl sulfide in significant amounts. A scientist from the University of Cambridge has remarked on the implications of these discoveries, noting that while K2-18b is indeed located within a habitable zone and contains carbon compounds, this doesn't necessarily mean that the planet can support life. The planet's size, with a radius 2.6 times that of Earth, suggests that its core is likely surrounded by a large, high-pressure mantle of ice, similar to Neptune's structure. This implies that while K2-18b has a thinner hydrogen-rich atmosphere and a sea-covered surface, the conditions inside these seas may be too extreme or unsuitable for life as we know it. Regardless of this, scientists have succeeded in capturing the most detailed atmospheric spectrum ever obtained for a habitable subneptune, allowing them to identify the molecular composition of its atmosphere with astounding precision. A researcher from Cardiff University explained that this accomplishment was made possible by meticulously analyzing the light emitted by K2-18b's host star as it passed through the exoplanet's atmosphere. K2-18b is classified as a transiting exoplanet, meaning that its brightness diminishes when it crosses in front of its host star from our vantage point. This dimming is how NASA's K2 mission initially identified K2-18b. The transit method allows a small piece of the star's light to filter through the exoplanet's atmosphere before reaching telescopes like the Webb, enabling cosmologists to study the composition of its atmosphere. The climate, by looking at these light signals, is pushing ahead the exploration group. Plans to utilize the Webb Telescope's mid-infrared spectrograph to further research K2-18b's air conditions are fully intent on affirming their underlying discoveries and revealing new data about the planet's environment. Their definitive goal is to distinguish indications of subsurface action on capable exoplanets, an undertaking that could altogether change our comprehension of the universe and our place within it. Notwithstanding its examination of K2-18b, the James Webb Space Telescope has additionally made other critical revelations that continue to expand our insight into the universe. For instance, astronomers utilizing the Webb Telescope have identified complex organic molecules in a far-off cosmic system that are comparable in nature to the smoke or brown haze we find on Earth. This revelation addresses the earliest known event of such atoms in the universe, marking an achievement in human history. These discoveries are both amazing and pivotal, as they challenge our understanding of cosmology and suggest that the universe was capable of producing complexity much sooner than previously suspected. To give some context, the light that cosmologists identified from this early world began its journey under 1.5 billion years after the Big Bang, while the actual universe is currently 13.8 billion years old. This implies that we are observing the beginning phases of the universe's development, so to speak. The most momentous part of this revelation is that it was made possible by the James Webb Space Telescope, which has the potential to make such observations for almost 1 billion more years. As we push the limits of our knowledge further back in time, we may, however, uncover more of these complex particles, perhaps from a period even closer to the Big Bang. This raises critical inquiries about our understanding of science and cosmology. Until the appearance of the Webb Telescope, past endeavors to detect complex organic particles in ancient galaxies could only affirm their presence or absence. However, Webb's essential mission now permits us to pinpoint the specific areas of these atoms within the cosmic system, providing insights into their distribution and concentration. Strangely, the non-uniform distribution of these atoms in the early cosmic system, known as SP41111847, remains a mystery that specialists still haven't completely unraveled. What is considerably more striking is that this early world, despite being just 1/10 the age of our Milky Way, was already as extensive as our own universe and had produced as much carbon and oxygen as the stars in the Milky Way. As humanity continues to wander into the unknown, armed with truly expanding knowledge and a deeper understanding of the universe, we are continually reminded of the immensity and complexity of the cosmos. Each new scientific advancement brings us one step closer to unraveling the secrets tucked away among the stars. As our organization of grandiose exploration develops, it is inevitable before the universe reveals significantly more of its secrets, shedding new insight into the significant inquiries we strive to address. As we continue to explore the universe with advanced tools like the James Webb Space Telescope, new discoveries are constantly reshaping our understanding of cosmic phenomena. One of the most invigorating aspects of these disclosures is the possibility to learn about the early universe and the evolution of vast structures. For example, The Webb Telescope's capacity to capture pictures and data from incredibly distant galaxies offers a brief look into the circumstances that prevailed soon after the Big Bang. This captivating information helps analysts unravel the mystery of cosmic evolution and the formation of the first galaxies, stars, and planets. The investigation of exoplanets, like K2-18b, is especially exciting because it opens up extra opportunities for discovering additional Earth-like life. Scientists are intrigued not only by whether life exists elsewhere, but also by how different such living organisms may be. By examining the atmospheres of far-off planets, researchers can search for biomarkers, pointers that life cycles might be occurring. These biomarkers could include an assortment of chemical mixtures or patterns typically associated with biological activity. Moreover, the Webb Telescope's cutting-edge technology allows for remarkable observations of star-forming regions, districts, and celestial nurseries. Regions are vital for figuring out how stars and planetary systems structure and advance over time. By concentrating on the light radiated from these districts, astronomers can gain insights into the processes prompting the arrangement of new stars and planets, as well as the circumstances that might be fundamental for the development of tenable worlds. In addition to concentrating on far-off universes and exoplanets, the James Webb Space Telescope is providing valuable data about the arrangement and development of our own Milky Way galaxy. By noticing distinct regions of the galaxy, scientists can analyze its structure, comprehend the distribution of stars and interstellar matter, and gain insights into the processes that have shaped its evolution. This information is essential for understanding the broader context in which our planetary system exists and for sorting out the history of our universe. One especially captivating area of research involves the investigation of cosmic microwave background radiation. This weak glow of radiation is a leftover of the Big Bang and conveys vital information about the early universe. By breaking down this radiation, researchers can gain insights into the conditions that existed not long after the universe began. The James Webb Telescope's observations can supplement data from various missions, like the Planck satellite, to provide a more extensive image of the universe's earliest stages. The innovative advancements of the James Webb Space Telescope also extend to its capacity to notice phenomena across different frequencies. While past telescopes have zeroed in on specific pieces of the electromagnetic spectrum, Webb's instruments cover a broad range of frequencies, from ultraviolet to mid-infrared. This extensive scope of perception allows researchers to study various astronomical processes and phenomena more meticulously, leading to more exhaustive and nuanced understandings of the universe. Notwithstanding its scientific contributions, the James Webb Telescope assumes a significant role in inspiring the upcoming generation of cosmologists and researchers by capturing staggering pictures of far-off galaxies, nebulae, and other celestial phenomena. The telescope sparks interest and wonder about the universe. These pictures often capture the imagination of students and young scientists, empowering them to pursue careers in science and engineering. Moreover, the collaborative nature of the Webb Telescope's mission highlights the significance of global cooperation in space exploration. The telescope is a joint effort involving NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. This cooperation brings together expertise and resources from all over the world, exhibiting the global commitment to advancing human knowledge and exploring the universe. As technology continues to advance, future space missions and telescopes will build upon the foundation laid by the Webb Telescope. These future missions may include even more powerful observatories or specialized instruments designed to test specific aspects of the universe. Each new mission will add to the ongoing work to figure out the universe and our place within it. In summary, the James Webb Space Telescope represents an astounding leap forward in our ability to explore and understand the universe. Its notable revelations, from the investigation of far-off exoplanets to the observation of early galaxies, are reshaping our insight into astronomical phenomena and providing new experiences into the fundamental processes governing the universe. As we continue to push the limits of space exploration, the Webb Telescope will undoubtedly play a vital role in revealing the secrets of the universe and inspiring future generations of scientists and explorers.